Let g be the function with the first derivative given by gx equals integral x0 e to the power of negative t squared dt. Which of the following must be true on the interval 0 is less than x less than 2?
Okay, so let's write a few things.
That was
We
really
have
confusing.
g prime of x. I'll make it simple. We know e to the power of anything. E value is always, what was it again? Positive or negative?
Positive.
Always positive. So we know if g prime of x is positive, so let's kind of think. If f prime is positive, then the original graph is going what? It's going up. So I'm going to draw this right here. Then g is going up. And then I want to find the second derivative because we're talking about concavity here. So we have to go ahead and look at the second derivative. And y'all should recall, when we derive the e, it is that itself times the derivative of the power, right? So in this case, we did say this is always positive. So it'll still be concave up. And our flashcard number 5 says, if double prime is positive, it is increasing and concave up. Do we see that? Okay, which one satisfies that condition? All three of them. A. Okay, let's go on to the next. Number 27. Ian, let's read that one real quick.
If x plus 2y times dy over dx equals 2x minus y, what is the value of the second derivative of y over x at the point 3, 0?
So we're going to eventually plug in x and y. But I want to make it look like dy over dx by itself. So I want to go ahead and take this and divide it by it. So we have dy over dx is equal to 2x minus y all over x plus 2y. To find the second derivative, we have to use our quotient rule. So second derivative is written as d squared y dx squared. So let's kind of recall. We did do one similar to it earlier today. The bottom is all to the power of what? All squared. Okay, and then the rule is we derive the top. Now, listen very carefully when we're deriving with multiple variables. If we're deriving with the x, it's good. But if we're deriving something without the x, at the end, it has to be dy over dx. Remember that, okay? So, what is the derivative of 2x? 2. And then derivative of negative 1y is negative 1, and we need dy over dx. And then I keep the bottom. And let's extend our fraction. Minus. Now I keep the top one as it is. 2x plus. Oh, I said plus. It's supposed to be minus. There we go. So it should be minus y. And derivative of 1x is simply 1. And derivative of 2y is plus 2. But what do I need at the end? dy over dx. Now at this point, all I need to do is plug it in and that's it. So we have, when I plug this in, let's go ahead and plug it into over here as well. Let's plug in the x and y on here. My x was 3, so 2 times 3 minus 0 all over. We got 3 plus 2 times 0. Isn't that basically 6 divided by 3? How many is 6 divided by 3?
2.
So any x, I'm going to go ahead and plug in the 2. So we have 2 minus 2. So question real quick. What is 2 minus 2?
0.
Do I even care about plugging the remaining in on the top? The left portion? I'm not going to worry about it. Let's plug into the next one. Minus. We have 2 times 3 minus 0. And then 1 plus 2 times 2. All divided by. Then we have 3 plus 2 times y. The y is 0. Okay, let's go ahead and simplify that. This piece is going to give me how many, Andrew?
Fall behind here a little bit. What'd you ask? Sorry.
So we have the negative, the 2, and the 3. When I multiply them, we get?
Negative 6.
Very good. And then, Ian, all that is going to give me?
5.
5 all over. And then 3 squared. We okay with the 9, right? And that's going to give me, I think I want to do like some simplification here. Let's do 2 over 3. 2 times 5 with the negative is going to give me negative 10 over 3. Which one's the right answer?
A.
A it is. It was kind of long, but it is doable. So if it is doable, even though it might take a long time, please do it. All right, let's go on to the last one, number 28. Ian, let's read that one.
For t is greater than or equal to 0, the position of a particle moving along the x-axis is given by x if t equals sine t minus cosine t. What is the acceleration of the particle at the point where the velocity is first equal to 0?
So we're looking at velocity and we're looking at acceleration. Let's worry about the velocity first. So my velocity is x prime of t, and we're going to let that equal to 0 by the given. Good? Okay? And then after that, we're going to find the acceleration. So we have a of t, which is x double prime of t. Essentially, we're just going to derive it from the velocity. So we're deriving twice. So my first derivative, v of t is equal to, what is our derivative of sine? Snow cone,
Cosine.
cosine. And then derivative of cosine is sine, or negative sine, so I need plus sine. And I need to set this equal to 0. So when I go over this, it's going to give me cosine of t is equal to negative sine of t. So now let's kind of dive into what y'all remember about trig from pre-cal. Back in pre-cal, for sine and cosine to be the same, y'all remember it had to be 45 degrees? Okay, so let's draw this. At 45 degrees, it is pi over 4. And I'm going to write out the next item just because I'm thinking ahead. It was negative 1, 1, root 2. And it's negative because we physically went left. Y'all good with that so far? And then another one. In quadrant 2, my x value is negative and sine value is positive. Y'all agree on that?
Wait, why did we go left?
We went left because I'm trying to prove this right here.
Oh, okay.
Okay? Just give me 2 seconds. So we know cosine right now is negative. So let's write negative. And I already have a negative here. Do y'all see my sign is positive here? So if all that is positive, what is negative times a positive? Also negative. So negative of the same number is equal to the negative of the exact same number. And so from there, let's go ahead and find, so we already found the angle. And specifically this angle measurement, is it actually pi over 4 or 3 pi over 4?
3 pi?
It is 3 pi over 4. And if you're thinking, how do we know? That's 0 pi. That is 4 pi over 4. 1 less of that is 3. Okay, I'm going to circle that because I'm thinking ahead. So we have a of t is equal to, now let's find the derivative of cosine. How many is that?
Negative sign.
Negative sine. And derivative of sine is just cosine. Cosine of t. And now we're plugging in 3 pi over 4. That's the last step. If you're like, this one is kind of hard, I'm going to say it probably is slight bit plus cosine of 3 pi over 4. And at this point, it's all about plugging things in. My sine is, we have our negative. I need to find opposite over hypotenuse. Do y'all see it's 1 over 2? 1 over root 2. And then we have minus, because my cosine is our negative, adjacent over hypotenuse, 1 over root 2. And what's annoying is they don't have that as an answer choice, because we have to simplify, rationalize. If I say my rationalize of this one is simply radical 2 over 2, do I have to prove that to you? Y'all good? Okay. The next one is minus radical 2 over 2. So we have two negatives of the radical, meaning 2 negative 2 radical 2 over 2. These two cancel out. Our final answer is negative root 2. So look at your answer choices.
A.
Should be what?
A.
A it is. Good job.